kinds of spooky things from my eye.
Yeah.
Yeah,
I call it the post information age.
Yeah, it's interesting. The information you're trying to iterate is statically and already required by the fact that it's industrial. Further on in services and there's some spooky things out there. But yeah, I've been in my program and mostly been immersive tech.
The ominous red light on the camera came on. Does that mean we're live?
Yes. The field of vision is pretty wide, so I don't think you need to worry about straying out of it.
Okay. Well, I'm glad they put an ominous light on it, so we know when we're being monitored.
Exactly. And if there's anything you're wanting to talk about that you don't want to be recorded on the record, I'm sure we can pause the stream or something.
I wouldn't. I just won't say those things.
Good. Because I actually think in all the years I've done this, I only once had a speaker say, "Don't record me, turn that off." But I did respect it when they told me that.
I've told people I don't want to be recorded anymore, and they just record me anyway, so I just.
No. Like, here where like somebody says no recording, we don't record.
At DEF CON once, and I knew this was being recorded. The whole thing was being recorded and streamed. But I got to this one slide and I said, "No one take a photo of this slide. This is a top secret slide." And everyone just taped their phones out and took a photo of the slide.
I was about to say at DEF CON, you're just daring them to take.
No, I wasn't. I mean, I knew they were. I didn't believe that they were gonna listen.
Right.
It was just funny how it's like they didn't take photos of any other slides. Only the one I told them not to take a photo of.
Exactly. Funny how human psychology works that way. We'll get started in just a couple minutes.
Sure, yeah, whenever you're ready.
Yeah, we already got enough people here. I can probably start at 7 on the dot.
Oh, great.
Yeah, because when we only have like 3 people, I'll often be like, let's wait 5 or 10 minutes. But we are doing good, so we'll get started right on the dot.
So he stood my face up there? Oh, no, I probably haven't. Yes, I see where I'm seeing the Navy Santa.
We're going to get started. You're ready?
You're ready. Yeah, let's do it.
All right, it's about 7 p.m., so I think we're going to get started here. Hello, everyone. Welcome to the monthly EFF-Austin meetup. See a lot of new and old faces as always, so welcome to both camps. For those who don't know, my name is Kevin Welch. I'm the current president of the board here at EFF-Austin. For those who are new and like, what is EFF-Austin? EFF-Austin is a local digital civil liberties advocacy group. We are closely affiliated with the Electronic Frontier Foundation, which is based out of San Francisco and has been around since the early 90s, as have we. They are the country's foremost digital civil liberties advocates, fighting for things like net neutrality, end-to-end encryption, First and Fourth Amendment protections in digital spaces, and just a gamut of wonderful good things. We are the oldest member of what is called the EFA, or the Electronic Frontier Alliance, which EFF sort of administers in a very non-hierarchical peer-to-peer fashion with about 20 or 30 groups scattered around the U.S. In fact, just about 3 weeks, month ago, there was the first official gathering of the EFA in San Francisco. So if any of you are not from Austin and you think, hey, I'd like to advance this cause, well, if your city probably either has a group like us or needs a group like us. So think about starting that. And I'll just also say EFF and EFF-Austin are both one of the main ways we're sustained is via donations from volunteers and followers. So, you know, if you feel like giving EFF money or us money, it's always greatly appreciated. Let's see, this is where I generally do a few boring announcements before I turn things over to the speaker. So let's see. First of all, we currently have our meetups on the second Tuesday of the month at 7 p.m. here at this location. Let's see. So originally, we were going to have a talk on cyber insurance for next month, but I've just literally been informed by the speaker that we now have an opening. So if you know somebody who might want to speak next month, get at me because I need to fill that. September, we're going to have a talk from our board member, Ritika Gopal. She's going to be talking specifically about Section 230 of the Digital Copyright Act, also known as the Safe Harbors provision. Basically, it is the nice little law that makes website holders not responsible for the things users post on them. It's a wonderful little law that lets the internet function, and it's under attack in certain quarters right now from some well-meaning people who do not understand the implications of getting rid of it. So Ritika is going to give us a sort of in-depth dive as a tech lawyer into Section 230 and discuss that a bit more. Let's see other things coming.
When is that?
That will be September's meetup. That's the only one we have actively booked right now. So yeah, if you know somebody who might want to speak in August or the remaining months of the year, get at me. We're especially interested in hearing from diverse voices that are not often heard in these tech conversations. So especially if it's somebody from an interesting or marginalized perspective who has something interesting to say about the electronic frontier, we are especially interested in hearing from people working in projects in this space from those communities. Let's see. Also, there's been a recent resumption of the Austin Indie Web meetups. They'd been on hiatus for a while, but they're back. They're usually the first Wednesday of the month at 6:30 to 7:30 p.m. at Mozart's Coffee on Lake Austin in Terrytown. So if you're interested in trying to collab on building technology solutions to build a social web without gatekeepers like Facebook, those are the people you should be hanging out with. They've been generous supporters of ours in the past. Don't actually have as much to report as usual because we just got through a couple of big events. We were sponsors at an event called Act Lab 2019, which just wrapped up at the Vortex Theater here in town. So, you know, we don't currently have any major events slotted up, but I just will say in general that if you find these causes interesting and want to get involved, get at me. We always need volunteers or even potential board members. So yeah, I don't think I actually have anything else I need to report right now. Okay, so I'm going to turn things over to our speaker here. Our speaker here is Dr. Brandon Wiley of the Operator Foundation. The Operator Foundation is a 501c3 that makes bespoke encrypted communications software for various people in third world countries battling, you know, government oppression or cartel oppression, you know, that sort of stuff, and allowing reporters and activists to communicate securely. So they do really awesome work, and you should also give them money if you have money. Dr. Wiley has spoken at the EFF-Austin meetup once before. He also just spoke at the recent concluded ACT Lab, and he's back with us again to talk about obfuscated exfiltration through adversarial networks. So yeah, without any further ado, take it away, Brandon.
All right, great. Thank you. So yeah, I give a lot of talks, and the audience is always different. So just want to get like gauge the temperature room. Like raise your hand if you are a programmer with a specialty in like network programming, PCAPs, Wireshark. We got a couple people. Okay, so for those people, it's going to be a little bit light on the code because I want to make it accessible for everybody. So if you're like there's no information in this presentation. Let's just get to it in the Q&A. I do have very technical information I can share with you about the work that we do. I'm happy to talk about it. I just didn't put it in the slides because sometimes when people see code in slides, they just kind of like, they're like, okay, this isn't for me. I'm gonna check out. So just kind of keep it light and fun. But I do want to get into the technical discussions. There's nothing wrong with that. Okay, so I am Dr. Brandon Wiley. I am the president of the Operator Foundation. We're an organization that makes tools for people focused on usability and security. So we make tools that help people access the internet in countries that block access to the internet as a means of political repression. And then we help people with like security and privacy. And we are a nonprofit, a 501c3 nonprofit. And so what we do is we do technology development, like in-house. We do hardware, we do software, but we do it specifically through this design process where we work with groups of people that are being oppressed. We make software like specifically for these like groups of people. So it's not like we have like an app that you can download from this app store that's like to fix the internet everywhere in the world. It's like we work with like specific groups only, which is a distinction between what we do and some of the other kind of like open source projects out there that are just like, here's this software, hopefully it will help you. And this is, we have a lot of people, that work on this. So we have the whole board and we have a whole team of, like programmers, designers, managers. So I don't want to make it sound like, this is just me that's doing this. We have a whole team that supports the effort. Like, we have an office and everything. So the internet, let's talk about the internet. What is it? Well, the internet is actually a network of wires strung all across the planet. So people think that the internet is wireless, and this is not correct. Even if you use Wi-Fi like you use your cell phone, because of the fact that radio waves diminish exponentially with the distance, it's not efficient to use wireless. So everything is wired for the most part, like 95%, and then like maybe the last little bit is wireless. And so this is a map of the international wires. So we have these big cables that we throw across the ocean, and then that's how we communicate to other countries. A lot of people think that we use satellites. Satellites do exist, but that is not how you are accessing networks, like websites in other countries. You're doing it through these undersea cables. And they're not even that big. This is one of these undersea cables. They get broken all the time, like ship anchors drag over them in international waters and they get cut. And the internet is actually very physically fragile in a lot of ways because it's just this set of wires. And essentially, all of these wires are plugged into some sort of device which is determining like where the data goes. And so this is like, I'm sure you've all seen like a consumer, like home router. The devices that power countrywide, like national level internet, are essentially the same device. They're a lot bigger. They have a lot more ports. There'll be like racks and racks of them. They cost a lot more money, but they are essentially the same. Some of the older ones are actually pretty much based on the same technology. So this is where the problem comes in, right? So the internet is a bunch of wires that are plugged into a bunch of routers like this. And the problem is that the people that administer these routers can decide anytime like, well, some of the traffic going through the router is fine and we're gonna let it through, and some of it we consider to be weird and we're gonna not allow it. And there's not really an easy way to get around this because everything's going through the router, and so the router has the say of what is passed through and what is not. So who here likes to do weird stuff on the internet? Anybody? A few people? A few people? Yeah? Okay. So let's talk about why we use the internet, why it's good, why people need it, why it's like a human rights issue that people have access to the internet. So there's a lot of different things people do on the internet. What we're talking about is not entertainment. We're talking about like important uses that people have in their day-to-day lives, like getting news, like educational material, material that you need for health and wellness. Also human rights monitoring. So people like governments that shut off the internet, if they're going to do some human rights abuses, they got some human rights abuses planned, they will shut off the internet first to make sure that there's no coverage of what's happening. Similarly, if there's going to be some election fraud, then they will shut off the internet just the day before the election and then turn it back on the day after the election so that nobody knows exactly what happened during the election. It's hard to do any kind of monitoring when you don't have the internet because that's what we rely on for our communications. So yeah, and then there's some other reasons that people block the internet. One is in many countries they have state-controlled media and don't want to allow people to access the internet because it's not, all of the websites on the internet have not been checked to be in agreement with the current political regime in the country. So therefore, free and open internet access is a problem. And another thing is suppressing civil unrest. When there are protests and things like that, often they'll block all internet access, kick out all of the journalists, and then no one is available to cover what's happening. And so in terms of what gets blocked, it's all of these are what the adversary would consider doing weird stuff on the internet, like going to the BBC website, going to CNN. These are not state-approved media outlets in some countries. And then of course you got to block all independent political sites because they could be saying anything for or against the government. And then all of the social networking, all of the chat apps, and all the video conferencing apps. Any way that you have free communication with a person outside of the country, they could be relaying information to you, which is based on them going to read the BBC website or whatever. And so any of this totally free peer-to-peer communication has to be blocked. So so if you do any of these things, then some government somewhere would consider you to be someone that likes to get weird on the internet, and you would be unable to do that. I have friends that sometimes travel and are very surprised to find that all of the sites that they rely on, for business purposes and things, are all blocked. In some countries, all of Google is blocked, every single Google service. So, right. So what we're talking about here is I like to, clarify as opposed to entertainment content and that sort of stuff is what sometimes people think about. We're talking about credible and topical sources of information that are important to people and their needs, right? And so I made this little acronym CATS, so it's easy to remember. So I'll be talking about CATS a lot in this presentation. Don't get confused. CATS is credible and topical sources of information, so just remember that.
But what if I get my information from actual cats?
Well, if you consider cats to be credible and they have topical information, that sounds fine. Yeah, so I'll talk a little bit about the history of filtering and circumvention from the basics all the way till today. So ever since routers have existed, ever since the internet existed, there's been some sort of blocking that was in place. Now, I'm going to use kind of a notation here. It's not what you might be used to if you're a network engineer. Talk about phone numbers. Very similar to how the internet works. The internet has this numerical addressing scheme. The numbers on the internet look a little bit different, but I feel like this is a more accessible way to describe it. So yeah, so in the beginning of the internet, when you wanted to connect to another computer, there weren't that many. There were 100 computers on the internet originally in the early days. So when you wanted to talk to another computer, you just have the number. Does anybody remember a phone number? Yes, a few people remember a phone number. I remember my childhood phone number is the only one that I remember. I'm not sure.
Mom, Dad.
Yeah, there you go. I don't even know if I know my current phone number.
I
But
know my girlfriend. I don't know.
yeah, so in the early days, this was normal to remember numbers, so you just type in the number that you wanted. So this made it very easy for the router because you just have a list of blocked numbers and you say, okay, well, that number is not allowed, so done, right? That website, you cannot access it. Very straightforward. And then, they can change their number, sure, but then they gotta broadcast that new information to everybody, and then they can just add that. And in fact, internet numbers are hierarchical, so you can just block the beginning prefix, and now you've blocked everything in that whole area. And so it makes it hard for people to just rotate numbers all of the time and get those fresh numbers to everybody. And so this address-based blocking, still very popular, still the very first thing that people go to. The solution is you got a proxy through another computer, right? So you dial out, you connect to a different number that's not blocked by your local router, and then from there, hopefully they're going through a different cable, and so they can connect, right? So this is fundamental to all of the censorship circumvention work that we do. Is you got to have some sort of a proxy, because otherwise they'll just block the number, and then you won't be able to connect. So always with the proxies. And in the more modern internet, we are used to name-based stuff. So you put in google.com, and then you get google.com. Actually, it's a numerical system underneath. And so what happens is we have the system kind of like a phone book, and you just look up, your computer automatically looks up the address of whatever computer you want to talk to, and then it connects numerically. So they can still do the numerical blocking. And in fact, this makes blocking easier because they can just put the name into the block list. So they can say, you know what, google.com, not allowed. Doesn't matter if Google has 100 different servers with all different numbers, they'll just put google.com in there.
Is that the DNS?
Yeah, DNS, yeah, is what DNS. I try not to use acronyms in my talks because the internet lingo is just like full of acronyms. But yeah, domain name system, DNS, is what we call this name resolution system. So yeah, DNS is one of the fundamental services of the internet that makes things actually easier to block, and it makes our job as people that try to get around blocking harder. Right, and so then this was all, originally just looking at the numbers, and that was, people said, oh, well, we can only ever look at the numbers because we have to do that anyway to route the packets of information to the right destinations. We're not gonna ever look at the actual content because it would be too computationally expensive. That's what people used to say like in like the 90s. So anyway, they eventually decided, well, we should start looking at the actual contents of the data and blocking based on that. So, and that's called deep packet inspection, is where deep just means let's look at the actual content of the conversation. And we all know that this happens, right? So like, if you put in like a query, and for people that came in late, CAT stands for credible and topical sources of information. So yeah, you put in a query and then it can just say, you know what, anything related to cats, we're gonna just block that. We don't care what website you're going to, we don't care what the name is, we don't care what its number is. If you say you want some cats, then we're gonna block that. So then you can go and you can like try to get around it by like, what query can I say that's not gonna be blocked? And then you can keep doing like more and more obscure sorts of codes. And people actually do this in places where they have a lot of this keyword-based censorship. There's a whole language that has evolved for communicating over censored chat channels where you say different words for all of the things that are blocked, and then like the dialogue, the vocabulary evolves like as a dialogue between the users. But it's a very kind of like human resources intensive sort of way to get around the blocking. And so this was also too much trouble for the adversaries to like keep having to add all these new keywords. So then they were like, well, what if we could just train some sort of like, AI to just sit and identify. So here, these are cats, i.e., credible and topical source of information. What if we could just find all of the things that look like cats and we'll just put them, anything that looks like that, we'll classify it as being bad. And so we'll call this the cat protocol, is just anything that resembles a cat. And so once you have this parameters defined, you can basically, train this algorithm that says, okay, I don't even care what you were looking for. If the information you got back conforms to this cat protocol, then I'm going to go ahead and just block it. And this is, a deeply technical topic that I, can talk about at length when we get to that section. But the important thing is just to know that whatever you're doing, there's some kind of protocol classification they can do. So like examples of this would be like, if you're doing like video streaming, they can tell that you're doing video streaming regardless of which video streaming service you're using or like which specific like content that you're viewing. There's like a certain pattern that's like the video streaming pattern, and they can just put that in and say, okay, no video streaming on this network would be an example. So that's the state of the art right now in blocking, is this protocol identification. Yeah. And yeah.
So it seemed like the one before where you were blocking just keywords.
Yes.
And this one, this protocol identification.
Yes.
It seems like the big difference is in the false positives versus the false negatives. So like in the keyword blocking, you get a lot of like false negatives of stuff that goes unblocked, which is why you can have languages, that sort of thing. But this one has a lot of false positives. So like my cat stuffed animal will still be identified in here. So you're basically moving the default to favoring blocking rather than not favoring.
Yes, I could see how you could get that from what I said. I don't think that that is actually the case in the way that protocol identification works. One of the problems with this whole false positives, false negatives idea is that the adversary doesn't always consider those to be like equal. Sometimes the adversary has more tolerance for one side or the other side, right? Like some adversaries are like, just block all the bad stuff, and if some other stuff gets blocked, fine. And some adversaries are like, well, let's not break the internet. Let's not get crazy. Like, let's just block like the stuff that we're sure about. And so in terms of these algorithms for protocol identification, there's a wide range that have different properties in terms of false positives and false negatives. But yeah, that's something, I'd love to talk more about. So something that people always ask me is, is this filtering that they're doing, is this legal? And usually there's no law that specifically gives anyone the power to do this filtering. Like what happens is they buy hardware that allows for filtering to occur, and then somebody that's really like empowered by any legal means to do this.
Also,
And,
isn't it like the governments that are usually doing this, and also the governments make the laws?
they usually just kind of start filtering the internet. There have been some cases, like there was a case where the UK was going to start filtering all internet with the idea of blocking pornography, and then if you wanted pornography, you had to like specifically request that your internet connection be like pornography enabled. And of course, the hardware for blocking pornography is the same hardware used for all the different sorts of filtering. So like once you have it in there, you can say, oh, it's for a specific purpose, we're only gonna use it for that. And then at some point somebody decides like, oh, but what if we just block things that are critical to the government? So yeah, and so this extra legal way that they do it, where they just kind of start filtering, has some issues of who has the power to decide what is blocked. How do you appeal? Like if your website is classified as something that should be blocked, and now people can't access your website, who do you talk to say, oh, you made a mistake, my website's fine, don't block it? And then who's accountable if they make mistakes? And the answer usually is we don't know who decides, and there's no appeal process, and there's no accountability. Okay, so let's talk about the other side. So we've talked about how people have been blocking content, how have people been getting around this. So we started with what we call these looks like nothing protocols. So the idea was, if we just randomize all of our internet traffic and we just make it look like noise, then no one will be able to block it because they won't be able to formulate a rule that classifies it as this is the traffic that should be blocked. So this is just a metaphorical representation of that. And it shows some of the issues with this approach. So first of all, you can still tell that this is a cat, I think, even though it's made of static, because even though it looks like noise, we didn't get all of the different characteristics of the traffic captured. So when people try to do this obfuscation of the traffic where they try to randomize it, if they don't have a clear picture of all of the different dimensions and properties that it has, you can have one that's very randomized and other dimensions that look the same as they did before. And if your model of what the adversary is doing is not the same as what the adversary is actually doing, then it can be totally ineffective to do this. So you're adding this whole layer, but you're not actually getting any benefit. And then the other problem with this is that this is a very sketchy sort of picture because it's made of noise. So you can basically train the classifier, like the protocol classifier, to say like, why don't you just find all the things that look like they're noise or made to look like noise, and let's just block all those things, because those things are all like things that we don't want, right? Like anything that looks totally random is probably some sort of circumvention tool or some sort of encrypted communication, and we don't want that, we don't need that, so just block all that stuff. So this was not a very effective means of obfuscation, this looks like nothing approach. So then we went to, protocol mimicry. So this is, let's pretend that all our traffic is a different protocol. So imagine there's this cat protocol, which is everything looks like cats. Imagine there's another protocol, banana protocol, everything looks like bananas. Let's just dress up our cat as a banana. Does this fool the sensor by pretending to be something? So an example of this, a concrete example is, let's make all our traffic look like web traffic, whatever that means, right? So, so the problem with this is a couple things. One is which protocol, like what traffic should we make our traffic look like? What's the safe traffic? And people used to say things like, well, encrypted web traffic will never be blocked anywhere because e-commerce, banking, stuff like that, it's untouchable. And so, that wasn't true. And eventually, a country decided that they were going to just block all the encrypted web traffic and only allow you to do unencrypted web traffic. So there is really no like untouchable protocol that you can make your traffic look like. You have to like look at the specific situation and like the specific adversary. So that was not very adaptable, that approach. So what we're working on at the Operator Foundation is what we call adaptive systems. So like, would you consider this to be a picture of a cat, right? At what point is this no longer a cat? Right? Where are we at? So whatever the threshold at which it became no longer a cat, for the adversary, for the machine that has the rules that's determining how to classify our traffic, that's where we set the threshold of obfuscation of our traffic. So we do transformations on the traffic right up until it becomes no longer identifiable by the algorithm, and then that's what we use to encode our traffic. So again, and this is a metaphor. So essentially we're trying to give nightmares to the machines that are trying to filter the internet. We want them to have a bad time and overheat and blow up. Okay, so people also ask me a lot, is what we're doing legal? Like providing these circumvention tools, is this legal? Well, one caveat, it depends on every country. There's every country has different laws, but I'm gonna give you just a general overview, which is, we can ask, is it legal to access these blocked sites? Well, because usually the countries don't actually pass a law that empowers them to block the sites, they also don't pass any law that says that accessing the sites is illegal. They simply block it. And if you get around the block, they'll just try to find a technical means to make it so that you still can't access those sites. In most countries, you're not going to be in legal trouble for accessing sites which have been blocked. Now, on the question of, is it legal to install these apps, these VPNs and proxies, various circumvention tools that allow you to access block sites, are you allowed to have those apps? And that, it depends. So in Dubai, for instance, you're not allowed to have any video conferencing apps. And so they will actually, when you come into Dubai, check your phone for Skype and delete it. And similarly, they don't allow VPN apps because that would allow you to access Skype, and they don't want to access Skype. In the case of Dubai, it's because they have a national telecommunications service that they want you to buy, and they don't want you to use Skype because then you don't have to buy long distance minutes. So it's not even really meant to be a human rights repression thing. It's just a commercial sort of
But
thing.
just like the UK example, the technology's there.
Yeah, it's all the same technology, right? So when people say oh, we got a reason that we're doing this, all it takes is a policy change internally for them to go from.
Is this person a citizen?
Yeah.
It's actually the two reasons. I lived in Dubai until last
really?
year, and
Oh,
I worked
interesting.
in Etisalat, the main operator there. So it's the two things. One, because of revenue things. So it's 60% government-owned operators, and long distance is a huge revenue for them. But there is a main concern about security concerns.
Yeah, sure.
So they want to be able to monitor whatever traffic that goes out of the country or within the country.
Sure.
But I haven't seen to be frank with you, I haven't seen that they are checking the Skype on mobile devices.
Okay, yeah, this is just something that I've heard. So in some places you're not allowed to have the apps, and then in some places they just make it illegal to sell apps that let you circumvent, and then in that case, the app stores will remove all of the apps, and then unless you have some means to get the software onto your device other than through an app store. So this is mainly for mobile devices like Apple App Store, Google App Store, they'll remove it if they say that you're not allowed to have it. And so that's a big problem, is just getting the software. Okay, so yeah, I wanted to talk a little bit about our process and how it is that we identify all these different adversaries and then make these custom solutions. So we have a whole process. We go from threat modeling on through to implementation. And so threat modeling is a very important stage that I feel sometimes when people are trying to make tools to help people access the internet, they skip this step. So the question is, for each tool that you're going to try to make for the specific country and the specific network, who is the adversary? What are they trying to accomplish? Why are they blocking things? A lot of times what we find is that the people that are running the networks are government employees. And so from 9 to 5 local time, you get a very quick response time if you try to do anything to circumvent. But after hours, there's no response until somebody comes, because everybody went home, because they want to go home to their families. They're just normal people. So if you can try to do your sketchy stuff on the network that you're trying to probe and experiment, you just do it outside of business hours. It's a lot more effective. And then what are their capabilities? So do they have a whole staff of some people that are filtering the internet just have some devices that they bought from a few different vendors in California, and they just install them. They have a web interface with some checkboxes block that block pornography, block gambling. They just check it off, and nobody really knows what's happening. Some people have whole teams that are looking at the live network traffic and developing new blocking rules and stuff. So I once had a device, and as we were testing it, the manufacturer of the device saw the traffic that we were passing through the device for our testing, saw that it wasn't being classified, and developed a new classification rule and patched all the devices in the world. So that was kind of like, the opposite of what we wanted. Like, we were trying to defeat them. It's okay. We got it after that. But yeah, so they were remote monitoring all of our traffic because it was a demo box. So apparently that was part of the demo rules, is they're allowed to see all the traffic you put through the box. So read those contracts. And then what is their tolerance of risk? So earlier we were talking about false positives, false negatives. Some adversaries don't really care if they break the internet, and some adversaries want to do the minimal change and block very conservatively only the things they know are for sure definitely things that they don't want on their network. And this is very important for how we're going to tweak our obfuscation technology for the specific adversary, is to make sure that we're thinking about their risk tolerance on like the false positive, false negative sort of axis. And then another step, just as important as start modeling, the needs assessment. So like, who are the people that we're trying to help? What are their goals? Why are they trying to access the internet? What are the resources that they're trying to access? Is it like YouTube? Is it like streaming video? Is it like text messaging? The shape of that bandwidth, the amount of bandwidth, it's going to determine like what sort of technology we deploy. And also, what are their technical capabilities? Like, can they set up their own servers and like we just have to provide the software? Do we need to provide like a turnkey solution? There's a lot of different variants in different countries with different groups that we work with. And then this is a question that I get a lot, so like, what is the tolerance of risk for the users? People have this, I think, misconception that the safest thing to do for the users is nothing, because if we give them some technology, it might get them in trouble for having this circumvention technology. What we've found is that most users are already doing whatever it takes to get access to the information they need, which can include some very risky behaviors. So they're like communicating on things that are totally insecure or are known to be whatever is worse than insecure. There are things where the government that they're trying to get around the blocking is actually providing the tool. The government will provide free VPN services that are actually logging all of your traffic. So they're letting you get around the blockade, but in exchange for capturing all your traffic and identifying who you are and everything. So, and sometimes when the users don't have a deep technical knowledge about digital security, they can't tell the difference between these different options, right? And so, so we always will only deploy technology to users if we're going to be reducing their risk, if we're going to be helping them without putting them at more risk than they already have. Fortunately, there's a lot that we can help the users with, because they tend to be doing pretty insecure things, like using unencrypted text messaging to talk about where they're going and what time they're going to be there, and just information that you don't want just everyone in the world to have. So once we have determined who the users are, who the adversary is, we do data collection. So here's the map of all the internet and all the different wires that connect the various different countries together. So the internet is actually it's complex, but if you look at a specific section, like a specific country, there's only so many ways in and out of the country. And so if you can monitor those, you basically have all of the information you need about the adversary. So we don't do any work in Australia, so I'm going to pick on Australia here. So here's a map of all the ways in and out of Australia. So if you monitor all of these, then you know everything about Australia's censorship, infrastructure. So what we would do is we would put some little, get some a server at these different parts of Australia, and so you can essentially geographically locate your server so that when you access resources in another country, you know which wire, which physical wire you're going through, and then there's also ways to manipulate the routing so that you can go through whichever wire you want. But the point is, these are all, each of these wires is, you know, I mean, some of them are by the same provider and some of them are different providers. You got to get a broad view of all the different providers in the country so you can figure out, they may have different hardware for filtering, they may have different filtering settings. So you got to build up this model. Well, I mean, at least we do. Like you could, you know, one vantage point would be better than nothing. If you can get all the vantage points in the country, that would be ideal. And then analysis. So we do our analysis of all, so we get all this network data. So we, you know, we have this, these different servers in the country, and we're looking at all the traffic coming in and out. And we're basically looking at which traffic is getting blocked and which traffic is getting let through. And then can we make a model of that so that we can figure out how the adversary is blocking. So like essentially like what are the filtering rules that they're using to determine what traffic to block and what traffic to let through. Now we could do this manually, but we like to use machine learning. So I'm going to just explain machine learning very briefly because I don't know if everybody is on the same page about it. Even people that are in the machine learning like industry have a different idea about what it is than I do. So I'm just going to tell you my definition and they'll all be on the same page. So machine learning is algorithms that create mathematical models based on observations, okay? So step one, algorithms. It's just programming. If you do any kind of programming, you can do machine learning programming. It's just writing code. And the difference is that you create these mathematical models, right? And so when I call it, say, mathematical model, it's just more code. So essentially you're writing code that generates more code. And the beautiful thing is it's based on observation. So like instead of us manually looking at all the traffic and coming up with what we think the rules are and then writing those rules in code, we can leave some of that work to the machine learning library and just do kind of the high level analysis. So here's a real concrete example. So this is some actual internet traffic, and there are two different types of traffic here. Now I could tell you, yes?
I just, real quick on the machine learning, could you mention what you are actually using, which software or packages are you using?
Oh, what software are we using for machine learning? Yes, so we use Apple's CoreML is what we use. And so the beauty of CoreML is that in the past you kind of had to have like a PhD in machine learning in order to get anything done. Or at least like the equivalent of like your own reading, because you had to choose like, what do I want? Do I want like a boosted tree model? Do I want like a SVM? You had to know all these terms, right? And so I know about all that stuff because I did this stuff for my dissertation. So I wrote like my own machine learning algorithms and stuff. But then in the modern day with the CoreML, it's like 3 lines, and it just chooses a model for you, and then you don't have to like know all of these details of all of these like algorithms and stuff. And so it's very beautiful. Yeah.
This is being used for characterizing what the filters are, or for the obfuscation?
Yes, so both. So we, so I'll get into that a little bit later, but yeah, so we both essentially reverse engineer how the filter is constructed using machine learning, and then we use that as the output to our adaptable obfuscation system. But yeah, so CoreML, we had written all this custom machine learning code and replaced it with like the 3 lines of CoreML, and it is like 100 times faster because our old stuff was not GPU accelerated, it was like all CPU bound, and CoreML just, it uses the CPU and the GPU, and if you can have like external GPUs and you can plug them in, it just does that all automatically. It's very beautiful. Unfortunately, our algorithms now, because we did all this conversion, only run not just on Apple products, but only on like an iMac with the maximum amount of RAM. So it's like we have to run all the analysis for everybody because they don't have the hardware that will do it. But the direction we're going to go is even more in that direction, where we're going to make it where our analysis requires like, you know, like 5 independent GPU. We're going to go just as far as we can, yeah.
Does the CoreML support like a serverless deploys of just spinning up Docker instances and just getting the whole internet's computing power, or like does it support that?
That's an interesting question. No, it doesn't support that. Although, you know, like Google's machine learning framework supports stuff like that, and so we've thought about other backends as well as possible. The CoreML stuff is mainly just it's like so easy, which is nice because, like I said before, I hand wrote all this stuff before, so like deleting all of my code and all of the bugs that was in it and just put in 3 lines of Swift was a beautiful day for us in the engineering team.
Cathartic.
Yeah, it was nice. It was nice.
I think
Okay.
rather than writing code, it's deleting code.
Right? It's the best way to solve bugs is delete all the code. Yeah, okay, so this is two different types of internet traffic. One that the adversary would consider to be totally fine, and one that the adversary would consider to be weird and in need of blocking. Now you can tell just by looking at these two images without knowing how I generated them and what they mean, you can tell that these are two different types of traffic, right? Like you got this band going left to right, and then over here you got this band going up to down. Like these are clearly different. And I'll explain to you what they are. So this is essentially all of the different letters that you can have. And this here, this band, is the like the English letters, and then this is like how where they occur in the data. So essentially, this is unencrypted web traffic, and this is encrypted web traffic. In unencrypted web traffic, you have English letters very prominent and going throughout the data. In encrypted web traffic, no prominence for English letters because it's encrypted, so all of the letters are equally likely. But also something that you'll notice here is like this is not totally just a big field of noise. This has some structure to it. People think, oh, we'll just encrypt everything and that'll hide it, and then we won't get blocked anymore. And that doesn't work because that's not how encrypted protocols work. Like encrypted protocols, the data is encrypted, so it's like hidden, so they don't know what data you're transmitting. But the encrypted protocols themselves have all of this structure that you can block just as well as unencrypted protocols. There's really no advantage from a blocking perspective. So anyway, my point is that we got these two different types of traffic. We can tell that they're different. We could definitely write some kind of algorithm that would tell which, given some traffic, which of these two categories that it's from. But wouldn't it be nice if we had an algorithm that could create a mathematical model based on observations? Then we just feed it all of our encrypted web traffic, our unencrypted web traffic, and it just generates this for us. And so that's exactly what machine learning does, and so that's what we use it for, and it's very effective. So then what we do after that, right, once we've done all this analysis and we have this model of the adversary, our tool is called Adversary Lab, so it's something that anybody can use to simulate an adversary. Like once we've modeled an adversary, you can import that and you can run your software, and you can see if your software would be blocked by our machine learning based adversary. You could do that all day in the lab and tweak your software and tweak your protocols until they pass, and then you can field deploy without having to have all of the hassle of going to another country and deploying things there that you don't know if they're going to work or not. So that's that's a service that we provide. Right. So then once we have it, we need to make this tunable, adaptive system, and so it's a very simple problem, right? So we have this weird traffic, and it looks like that, and we just want to make it look like the normal traffic, whatever that happens to be for the specific adversary at the specific time. That's all we want to do, is we want to come up with some transformation, some algorithm that will transform the traffic for us. And can we do that? Is that possible? Of course it's possible. It's data, it's code. Of course there's like an answer, but how do we find the answer? Well, right, machine learning, right? So we use the machine learning model because any machine learning model has two different phases, right? One is a classifier where you give it some data and you say, is this data from this category or this category? And it will tell you which category it's from. But you can also run it backwards and you can say, okay, I would like some data from this category, from the normal category, and it will generate something that based on its model would be classified into that category. So basically we would just run the machine learning backwards, and then that gives us our obfuscation algorithm that is adaptive to all these different specific deployment scenarios. And sometimes when I tell people this, they say, well, is that going to work though? Like when we generate traffic using this machine learning, it's called a regressor, is that going to actually fool? Is it going to look enough like the traffic that the adversary is looking at? Is it going to look good enough that the router is going to let it through? Like, will it be able to fool the router? And the question is, yes, for sure, because I showed you this picture of cats earlier. This was totally generated by a machine learning regressor. None of these are real cats. These are all machine-generated cats. So if earlier, thank you, if earlier in the presentation you thought those were real cats, if we could fool you, we can fool like a router, which is just, it's just like some code and some algorithms. So, and we do, we do all the time. So, cool, so that is the end of my prepared remarks, and we can just get into questions.
We've got all these interesting new chips arriving, and that do things even faster. We
have, instead of GPUs now, they're IPUs. And different mathematical approaches, in case the IPU is infrequent sparse matrix or things like that. So, and a lot of this magic is probably done in something like a network bus, to make the obfuscator. So a country rather, that owns the newest processors and produces the network boxes would be the one that would be able to get through the other guy's stuff. I mean, almost like there's warfare going on. My troops get through your minefield and I stop all yours, I mean, whatever.
Yeah, well, so the way the actual economics of network filtering works is that most of the countries buy their stuff from the same set of vendors. There's like 5 vendors in California that make most of the hardware. And so most people buy their stuff from the same set of vendors, and they spend millions of dollars, tens of millions of dollars, hundreds of millions of dollars on their countrywide internet infrastructure, and they don't want to upgrade their hardware. So a lot of the hardware is really old and slow, and some of the attacks that we do are attacks that you would think, oh, well, that would never work because that's like so easy. But in fact, because the hardware is from the 90s, that's the attack that's going to be effective. And some of the kind of more complex attacks are not even that effective because they're not addressing, the very simple attack.
Trend in networking.
Oh, thank you so much.
On the hardware side. And that is to handle this 5th generation network, and who knows, we'll put a blockchain inside the boxes. They're going to be much more sophisticated. So now if I get one of those more sophisticated boxes.
Yeah, so yeah, I would say that there's eventually some countries are going to upgrade their hardware, and the vendors would of course love that because they don't sell you one box. They sell you, like a minute. Like these boxes are like $20,000 each. You have to buy like a couple million of them at a time. That's like how the contracts work.
And they also go to a new kind of paradigm called network splicing, which I have to think would run you crazy because you have to put a processor on each of them.
Oh,
you have to discover the slices, which maybe stay within the protocols. You can do that. But now you've got many more to analyze.
I don't know about that. Let's get some more questions. Yes.
So it seems like a lot of these classifier upgrades are fairly short-lived, or can be short-lived. The parallel that kind of comes into my mind is things like superbugs in medicine, and it seems like the more you get the more you experience that, the more immune the superbug becomes to it. And so is there a fine line about like, oh, we have this really, really awesome one that can really get through a ton of stuff, but we don't want to use it that much because then the adversary will learn about it more and will be able to classify it better? Like, is that a balance you have to consider?
Yeah, that's a great question. We often talk about in the circumvention world the idea of coming up with multiple multiple obfuscation techniques and then like not releasing them all at once. I have never seen that happen. People always, in my experience, use their most sophisticated technology like immediately because they want to get all the users back online that are currently offline. And so this idea of like holding back and releasing it later, it's a great, we definitely talk about it all the time, but like nobody ever does it. Or if they do it, they don't tell me about it, so I don't know that they have this other secret stuff. So what we're trying to do with our adaptive systems now is shorten the cycle, because the cycle for coming up with a new obfuscation technique was like a year or something, because somebody that was like researching, like somebody like an academic, somebody doing their like PhD dissertation would have to come up with a new idea for a way to do obfuscation, and they would have to like code that up and then release it, and then have to get up in all the tools, and then maybe it takes the filters like a year to because it has to get popular enough for them to bother with. Like they don't just filter every crazy thing that any academic has ever come up with. Like they wait until the tool like has a bunch of users, and then it kind of comes to the top of their priority list. And again, these are government employees usually who want to go home, so they're not doing any extra. They're just like, they're told like, okay, now you got to block like Telegram or whatever. So they're like, okay, today we're blocking Telegram. So So yeah, so we had like, it was like a year on each side, like a year to make a new obfuscation method, a year to make a new, for the filters to like notice and to block it. And so what we're trying to do is to reduce that cycle where with our systems, we have the system called Replicant, which is adversary tunable. And so, you know, essentially like when we detect that there's new blocking happening, we can deploy a new configuration without having to like invent a whole new obfuscation technique, code it up and get it adopted, right? Like our thing is basically, so adaptive that you can just change the config files rather than like rewriting the
Not
whole
only
thing.
adaptive, but also agile.
Yeah, adaptive and agile, yeah, I would say. So that's what we're trying to work on, is like reducing the time on our side. And I'm sure that on the filtering side, there's also efforts, you know, to reduce their time to detect, you know, and block things. But again, it's like, you know, it takes a while because unless it's like a really popular service which like switches out their obfuscation and like went from 40 million people using this thing today to 40 million people using this obfuscation model, unless it's that sort of scenario, then it's like going to take a while before they're going to even notice that it's on the network.
So first movers
You know?
get some extra hidiness.
Yes, well, yeah, I guess, yeah. I guess, yeah, first movers have an advantage. Yeah.
So I have two questions. So the first one is, if you're using a machine learning model to do, did you say regression across?
Yeah, classification and regression, yeah.
So you're using regression in order to obfuscate the technique. How do you deobfuscate on the other end?
Oh,
Because
yeah.
machine learning is non-deterministic. So
Yeah, it's a great question. So essentially what, what we're doing is we're using the, excuse me, we're using the machine learning to generate parameters for our obfuscation technology. We're not actually using the machine learning like directly in line in the network stack. Like, so we're freezing a specific set of parameters that the machine learning came up with, and we said, okay, we're gonna use these parameters now for this communication. So the client and the server both need to have the same set of configuration options, and this is true across all different types of obfuscation. You always have to proxy through some proxy server that speaks the weird protocol that you're pretending to be or whatever, like knows all the weird encryption you're using and stuff like that. So you always have to proxy with the server, and then you always have to have the same configuration, because if you have a different configuration, they're gonna not have any idea what it is that you're saying to them. But yeah, so essentially, yeah, we're freezing the parameters. So we would, you know, someday we'd like to do something with like adaptive machine learning, where like the machine learning is actually learning as the traffic is coming through and stuff. But getting like propagating those parameters so that as the machine learning model updates, everybody has the new set of parameters is its own kind of unique challenge in the space. Yeah. No question?
Yeah. So, like in your Australia example, it seems like you have a few like VPN boxes in several server farms like in the country's perimeter. What stops them from sort of identifying that you're doing this and just blocking those boxes or
Yeah.
remove them or whatever?
Yeah, sure. So when we're doing like network reconnaissance to try to gather the data to build the model, like how do we not get detected? Well, so first of all, our test boxes are like our test servers in country and our test servers out of country that we're communicating to, so that we can see the traffic like cross through the filter. Those are both not used for anything other than testing. So the amount of traffic that they're passing is small. It's very small on like a national level. The only thing that would maybe get us in trouble where we would get blocked is that maybe the traffic we're sending is like weird, because when we're like probing the firewall, to some extent we might be just sending totally normal traffic, like web traffic, and if it gets blocked, well, so is everybody else in the country. They're all getting blocked by the same rules, so we're not doing something specific sketchy. But sometimes, we might want to do some more kind of active probing where we maybe send a bunch of different types of traffic and see what gets blocked and what doesn't get blocked. And, that could be something that might raise some suspicion if the system administrator was looking. But yeah, I would say it's just the volume that we're doing is so small that it doesn't really throw any flags.
So the actual production obfuscation, is that happening on the end user's client device? It's not happening at a proxy you own?
Yeah, so obfuscation always has to have a client on the end user device, okay, and then a server that is speaking the same protocol, and then it proxies through that to someone else. So that we as an organization, do not provide any services whatsoever. We only do technology development. So we will provide the server software, but we don't run any proxies. Other organizations do run like whole big proxy networks, and that's like part of their value add. The reason we don't run services is because if we don't run a service, we don't have any user data, and no one can ask us for the user data, and so we don't have the possibility of putting users in danger because we don't have any of the user data. So we work with the partners, and then our partners in each country will deploy their own servers, like using our software. Yes?
You said that you build the models on your own machines. So how do you avoid single point of failure on distribution?
Yeah, well, so we build the models. Yeah, we do. We have like a big, like a decked out iMac that with all the GPU power and like lots of RAM and everything. So yeah, we do build the models. We don't build models like very frequently. So we'll get, so we're all grant, we're 501c3, we're like grant funded and donation funded. So we'll get a grant that will include like make a model of this network or make a model for this specific circumvention tool to see if their traffic would get blocked. And so we do this kind of contract-based model creation. So yeah, it's not a point of failure, just that it's like not a part of the critical path of deployment. Like we only do it occasionally. But I will say, yeah, if our iMac broke, we would definitely need to get a new iMac because it just, like it doesn't run on any other machines anymore. We'd probably get a Mac Pro next because I want more RAM. I'd like 128 gigs of RAM. Would be like really good. But yeah, our thing crashes like
1.4 terabytes.
Yeah. Oh, really? Oh, wow. Yeah. So we have like 16 gigs in our laptops, and my developer that works on this is always trying to get it to run on her laptop because she doesn't want to go in the office and do it on the iMac. And it immediately, the very first packet you analyze, it immediately eats 16 gigs of RAM, and then crashes your machine if you don't have like more than 16 gigs. Like it has to do with like the specific analysis that we do on sequences of bytes that occur in the data stream. Like when you do the math on all the possible sequences of bytes that could occur in a packet at all different offsets, it's a lot of data. And so even that first packet generates like 16 gigs of data in the database. We actually wrote, this is getting to technical weeds, but we use a database called Redis, and we actually wrote our own Redis module because it was everything else was too slow. So we have this Redis module. It actually runs inside the database and does this like sequence analysis. So inside of the Redis database, like the first write you do, it just immediately takes up all of your memory and crashes your machine. It's beautiful in a way.
Like a fireworks burst.
Yeah. Other questions? Yes.
Has any adversary caught on to this? Are they what? This all sounds great. What's the downside?
Oh, well, okay. So in terms of the adversaries caught up, yeah, so the adversaries are very active, and they're different levels on different countries, right? Some people, they just like set it up and then configure it and forget it. Some adversaries actually do active probing. So like when people run these proxy servers, they will actually, if you connect to a server outside the country with a protocol that is not easily classified as one of the OK protocols, like it looks a little weird or whatever, they'll actually connect to that server and say, hey, server are you? And if you're like, I'm a Tor server or whatever, one of the block things, or like, I'm an OpenVPN server, then they'll block you because that is, in that country, like not an allowed traffic. So they're actually actively probing. Some of these services provide a set of proxies, and so what the adversary will do is try to find the numerical addresses of all of the proxies and then block all of those like in the filter, right? So that's still like, that was at the very beginning of the talk, like numerical address blocking is still very much like the main thing that people do. So yeah, so they'll do things like, they'll even like if your software, when you download it, comes with a set of proxy addresses, they will download your software, look at it, find that set, and then add that to the list, right? So they'll figure out however you're distributing the list of proxies, and they'll get them all blocked. It's very cheap to block the proxies based on address. You don't have to do any protocol identification. You don't have to look at any, there is no traffic to look at, right? Like it just, Kaiser will go to that IP, and that IP is blocked, and so then it's over. So, so yeah, the adversaries, I would say, yeah, they catch on all the time to all the different things that everybody's doing, and it's very active on both sides. It's a whole kind of field, like there's a lot of people that work in this space that we work with, all these different circumvention tools, and all these different people researching obfuscation and stuff. So yeah, it's very active on both sides for sure. Yeah.
This is kind of following up on that a little bit. So I've had a sense for some years I've been doing research in cybersecurity that the cycles of innovation and sandboxing favored a lot of the bad actors because they were doing stuff so quickly. But with machine learning and AI now being configured to deal with information security more in the last few years, I'm kind of getting a sense now that countries with governments with big budgets and deep cultures of academic work in AI now have more of an advantage, like the US, England, and Germany, and China, and a few others, as opposed to maybe some of the places, Russia, the others that maybe don't have quite the same culture and deep budgets of academic work. Does that sound true to you? And do you think that's going to stay true with open source tools like TensorFlow and others where anybody can do machine learning?
Yeah, so yeah, I mean, I would say that the people that are willing to build their own hardware have a big advantage in terms of effective blocking, because the hardware that's out there commercially is it's just so old, and it's just not being updated. There's a few like startups that are doing some really good blocking technology. See, I'm not like a fan of the blocking technology, but I get excited when they're doing a good job because it's just like a puzzle for us to solve. But the problem with these innovative like startups is that they can't sell to these governments, right? So it's like if you have this culture, like you were saying, if you have a culture of interaction between academia and the people that are like producing like commercial goods and the government, then that's going to give you an advantage. Because like I see like these people like in Sweden doing like great filtering devices. I'm not going to tell you the vendor because I don't want like people to go buy these filtering devices. But anyway, they're like excellent. But people aren't buying them because they don't have the deal flow. Like the people in Sweden don't have, you know, like all these different governments of other countries like coming to them to buy boxes. So there's never going to be successful in this market. There's a lot of markets like this where like it's not about innovation, it's about having connections to the institution. But I think that we actually have an advantage on the circumvention side over the blocking side, like a technical advantage, like a fundamental information theory-based technical advantage that we will always have an edge doing circumvention over people that are trying to do blocking. And it's like, I can't get into it because it would take too long. Maybe later at the bar we can talk about it. Yes?
I was just curious, which types of traffic are you typically trying to like filter or unfilter, I guess? Like what, is it like network, is it just like voice communication, video, or just, you know, text messages, or what's the state?
Yeah, so it's different every country, like what is blocked and like what the users are trying to access. But a lot of the people that we work with are circumvention tools. So it's like a proxy or like a VPN or something that it's not for a specific like application use. It's just like unblocks your internet on your phone or like on your computer or whatever. Those are a lot of the people that tend to be interested like in working with us. So like a big thing that we've been working on is OpenVPN, which is like a really popular open source like free VPN, right? So VPN, people don't know what VPN, it's like software that allows you to like take all your network traffic and send it through like some proxy server before it goes on. A lot of times people use it to access their corporate network. So like you're traveling and you want to access your sensitive files back at your office, and so you use this VPN software. But people have been using it to bypass internet censorship and like filtering and blocking stuff in a lot of countries. So yeah, so OpenVPN, we've been working with that team. We actually got our technology into OpenVPN. So they're going to be in the next release of OpenVPN, hopefully, going to be shipping that out so that all OpenVPN servers and clients, you know, in the world, when people update, will have this technology, and you'll be able to use all the different obfuscation techniques that we come up with and that other people come up with, and you know, put them in there. So and then some other VPNs like TunnelBear is one of our favorites. TunnelBear uses some of the technology that we worked on. It's a very cute VPN software. It has a bear that like pops up whenever your VPN is on to let you know you're safe. It's very cute. And yeah, and then there's like these like specialty sort of things like for different countries where they kind of specialize. But in terms of like what gets blocked, I would say chat apps, very popular thing to block. Video conferencing, like WhatsApp is one of the most blocked apps ever. I've never even used WhatsApp, but it's like just very popular all over the world and very, very blocked. And like Google, YouTube, Facebook probably the most blocked service just because it's everywhere and people love to use it and they love it to use it as a means of communication. But But yeah, it varies a lot. Yeah.
So back to the example of like the Deep Dream cat and like
Yeah. That's my favorite part of the presentation. I spent the most time on that. Yeah.
It was pretty good. Did you make that Deep Dream yourself, or?
No, this is all just like freely licensed, you know, free for reuse images from Google Image Search.
Well, one thing about Deep Dream is that like they'll all look different, but they'll all look like Deep Dream.
Yeah.
And even with that, once you do that, it's still, you can kind of see that it's still Deep Dream.
Yeah.
And I'm wondering, is like, so you have this model or this machine learning algorithm that generates these models, and what it's making, what your obfuscation system makes is different with each model, but is there sort of a fingerprint of like, yeah, but it kind of always looks like Deep Dream?
Yes, that's a great question. That's a great question. So can you fingerprint our technology that was meant to obfuscate things to avoid the existing fingerprints?
Just like
and you
how
make a new fingerprint for this.
Yeah, just like how they're like, well, it's encrypted. We're just gonna remove all encrypted. Well, it's Deep Dream. Let's remove
So
all Deep Dream.
theoretically, I can't give you an answer because it would be, it's like
Against your best interest.
No. I mean, like, there's no theoretical answer to that question. It's like related to like computability theorems and stuff, like about whether or not you can always find a way to fingerprint. My intuition, having done my dissertation on this, is that we have an advantage in generating like fingerprint-free sort of encodings. But yeah, we can't prove that there's no way to fingerprint it. The best way, to see if there is a way to fingerprint it is if someone blocks it, then we can go analyze that. Now, it's possible, that like our whole machine learning system might have some kind of flaw in it where it like, doesn't capture, like for instance, if you don't capture all the dimensions, that's a big problem. So a lot of my work in my dissertation was figuring out what are the dimensions of internet traffic that routers actually look at. Because people come up with a lot of different sort of properties that they would like to talk about in the literature, but when you actually look at the hardware that I've examined like focuses on some very specific properties, and so those are the ones that we obfuscate. But there could always be some, unthought of property of the traffic that we're not looking at that somebody else discovers. I think though that when that happens, that we will find out what that property is, and then we will incorporate it into the system, and then we'll be back.
I've noticed that all of your traffic ends with "brought to you by Dr. Brandon Wiley."
And it's funny. So some early obfuscation techniques, actually, it's very common in internet protocols to start the very first byte of the very first like data that you send to be like, hello, I am this internet protocol. Here's which one I am. Very common, very friendly thing to do in internet protocol design, right? So when people were designing these obfuscating protocols, these look like nothing protocols that were supposed to be all noise, they would still, because they're from this culture.
Hello, I'm the noise protocol.
Yes, they would start with an identifier, and I'd be like, this is the opposite of what is good, because now things that were not getting blocked are going to all get blocked because that's the first thing that you say. And there's actually a problem even like with encrypted traffic. So in Adversary Lab, our tool that will like classify traffic and become like a simulated adversary, we have many times been able to look at two different types of encrypted web traffic, one that's real and one that's from a tool that pretends to be encrypted web traffic. And we were able to get a sequence of bytes out of the beginning of the traffic that totally 100%, not 100%, 70% maybe identifies the fake encrypted web traffic. Yes?
Thank you very much. By the way, do you have any idea how successful this classification algorithm can penetrate different firewalls, like different regions and areas, besides your experiments in Australia? Do you have any idea how the real tool has been, how successful are they in penetrating different governments' firewalls? Or
Yeah, so I want to make it clear, we didn't do an experiment in Australia. I used Australia as an example because we do not do any work in Australia. So I just used that in my slide. We definitely don't do any work in Australia. They don't really have any kind of like repressive filtering for us to address. And it's also, no one will give us money to help people in Australia. It's not considered like an endangered area. It's
Well,
like
I don't know.
fine.
I've been hearing they've been threatening to pass a lot of really bad internet censorship
Yes, you see,
laws.
threatening to pass a law is not the same as doing. This is what happened in the
This
UK.
doesn't generate budget for you.
Yeah. The same in the UK. They're like, we're going to filter stuff, and then they didn't, and it's fine. But anyway, to your actual question, do we know how effective it is? Well, that's a broad question because there's a lot of different countries that we operate in. So our new technology, the replicant, tunable sort of adaptive stuff, we have not launched that. That's like the current cutting edge stuff that we're developing. The older stuff, like the looks like nothing and the protocol mimicry, I would say for the most part, some form of obfuscation works in most countries. There are, for each obfuscation method that people have like actually coded up and released and is like in the wild and like being used, there are different countries where it works and different countries where it's blocked. There are no methods currently deployed that work everywhere. It's definitely on a country by country basis. But so I would say overall this whole obfuscation technology has been very, very effective, but none of the specific methods have been overwhelmingly effective. They've all been,
So a lot of these are driven by economic conditions.
What's driven by economic conditions?
The success is driven by the economic issues about installing the filtering.
Well, that's part, it's a complex issue. So there's like the capabilities of the filtering systems, there's the policies, because in order for one of these obfuscation methods to be blocked, someone has to decide to block it and tell people to block it, then they have to do all of the work to do it.
So we have to pay people, we have to...
Well, yeah, sure, but also it's just, some of them are more on the radar or not for different countries.
Have your
different levels.
obfuscation methods ever been blocked? The ones created by these models?
Oh, no, see, that's the stuff we haven't released yet. That's our cutting edge technology that's coming out next year. We're still doing data collection and stuff on that.
Do you have any sort of cryptographic security built into your stuff, or is it just about the obfuscation?
So our goal is just obfuscation. So we do use encryption, but we do not use encryption for the purpose of privacy of the data. That is the job of the application. All we're doing, you can think of us as just a technique to get across the firewall, and everything else is your own business. But we do use cryptography, and because we don't want people to hate us, we do always try to follow all of the best practices for using cryptography, even though we're not using it for security. Just in case someone gets confused, doing a code audit and says you did this wrong, we always try to do everything perfectly. But yeah, we only use it to remove properties rather than actually secure the data. Yeah.
So many censorship regimes online basically revolve around header or metadata attacks. We see attempts to get around some of these problems like DNS over HTTPS or proposals to encrypt the server name identification field. I remember reading recently that Google has recently piloted a technology that lets two people share private encrypted data sets without either party being able to see the other's data set, but you can still perform operations. I'm wondering do you think maybe we could take some regimes of doing a similar thing with the metadata on these protocols, and we encrypt everything and we use these sharing techniques to still route things where it needs to go, but nobody, including the person running the router, knows anything about the metadata because it all stays encrypted by the protocols?
Sure, yeah.
Do you know anybody going in that direction?
I know some people that work on stuff like that in the 90s.
Is there a reason it's a bad idea because you say the 90s?
No, that's just a lot of the cool ideas that people come up with now, people were doing them in the 90s and then we just forgot that happened. And so that was, so actually Tor, a lot of people know Tor, it's the most popular circumvention tool in the world, TOR. Very popular, used by everybody. The Tor developers, before they started working on Tor, they had a project called Freehaven that was the same people that started Tor. And it used something along those lines, this kind of sharding, M of N shares cryptography sort of stuff. It was slightly different because it wasn't for routing information. It was for like essentially like we can have web servers that are holding content, but they don't know what content it is, and they can't give up the content. They can just give you the share, and then you got to get it from multiple shares. But it was the same kind of cryptographic technology that you're talking about. You know, all I can say about that was they left Oregon Freehaven to work on tour, so they must, yeah, I don't know. You got to talk to them about that. But yeah, I don't know. It sounds cool to me.
So it doesn't sound like total bunk to you.
I'm into it. I'm into it. You should check out. This is not exactly. This is not like the idea that you just pitched, but it's like if you like that idea, you're gonna like this idea too. There's a thing called decoy routing, which they now call refraction routing. They have a lot of people and money. I think they're gonna definitely do something. But it's refraction routing. Check that out. You're gonna read a bunch of papers about it. Yeah.
So your presentation was tuned towards somebody who does not know how the internet works, right?
Well, just for everybody. Get everyone on the same page.
Amazing. Fantastic job
Okay, great.
at being able to present this in such an accessible way. Who is the audience for this sort of education? Is it people who are potential grant, somebody who can write you a check for something? Are they advocates in places where you want to say, hey, this is important, you should pay attention to this sort of stuff? Or is it like politicians who aren't even aware that there was a sysadmin who turned on the routing in the country, or the filtering in the country? Like, who is the target of this sort of a dumbing down of the technology?
Well, I wrote this for you. This isn't just like a talk that I give all the time. Like this is.
To sidebar a little bit, my request for Brandon is to not make it technically bereft, but also make it accessible.
Yeah, so I mean, I give a lot of talks, and like I've talked at DEF CON, which is like a big hacker conference. I was just talking at the ACT Lab conference, which is like a new media conference. So yeah, I give a lot of different talks, but I do different like slides for all the different talks. So this is the presentation that I made for this audience. So
And I guess for me to get on my little soapbox, we feel it's important that the electronic frontier is for everyone, those who are both technically literate and those who are not. So we try to make these meetings welcoming, even if you don't have a PhD in computer science.
So I guess the real question is, what is the EFF for? Who are their target? Who's their target?
Again, it's you.
Well, I don't want to necessarily speak on behalf of them because we are a legally distinct entity from EFF. But
So what about EFF-Austin?
What is our target? I mean, we are primarily an educational institution who occasionally dabbles in political advocacy and throwing cool parties.
What are you educating? The kindergartners or?
All ranges. I mean, we've actually wanted to do more education in the schools. It's been something we've talked about. We just haven't done it yet. But I mean, frankly, a lot of it's just for you all to come here and learn about things that you may not have heard about yet.
Let's get back to
You can be
this
the
question.
We can be the apostle.
What's your question?
So specifically on the point on like educating an audience who is not necessarily super familiar with this, a lot of these filtering techniques and stuff are like done by governments who aren't super educated on the topics. Is this an effective way of educating them on the topics? Have you seen this work before? Like you give this presentation in England, there are some like people who were elected to office or some politician is like, my God, like we have to roll this back. This is like a huge thing.
No, I don't get invited to those sorts of talks.
I mean, sidebar on that question, I literally came across a news article today about politicians in England freaking out about DNS over HTTPS because it's going to let everyone get around their stupid porn filters.
Right? Yes.
Mine's real quick, I think. The question was, so you were talking about encrypting all the traffic versus individual types of protocols. If I am a person that is interested in protecting something I do, should I protect everything I do, or should I protect only the things I think will get me in trouble and do the other stuff and be clear and make it look normal?
Oh, well, it's an interesting question. I
That's
guess
meta paranoia.
it depends on the adversary, because there are some networks in which using an encrypted protocol will flag you for additional like scrutiny. So I would say the best thing to do is encrypt everything and then run one of these obfuscation techniques so that it doesn't look encrypted. Is number one best thing to do. And so so personally I always use a VPN everywhere, like whenever I'm traveling, because you can't trust like hotel Wi-Fi or coffee shop Wi-Fi or anything that's Wi-Fi. You just can't trust them. And so I just always use a VPN and then with the obfuscation turned on, because VPNs are now blocked in a lot of countries. So if you're traveling around the world, you probably can't just use a VPN. It probably won't work. So you gotta have the obfuscation technology. Yeah.
Have you considered using this
You're next.
offensive technique rather than
defensive?
rather than a protection technique?
Have we considered weaponizing the technology?
Yes.
No, we're a nonprofit, so we haven't thought about that. Yes.
What is the expansion factor of the data like? I imagine like doing this encoding would require some expansion.
It's a great question. So when you do these transformations on the data, since we're not doing compression, the data is going to be either, in best case, the same size, or worst case, like much bigger, right? So that's what the question is. So my dissertation work was on a predecessor of this. That's called Dust. And Dust, the idea of Dust was obfuscate at all costs. It doesn't matter what the expansion factor is. Let's just get it through any imaginable adversary. And so there, the expansion factor was unbounded, and it just depended on what your settings were. With Replicant, which is our new technology, we are trying to be very bandwidth conscious, and so we actually have a constant expansion factor. What that specific constant is it depends on your settings, but an additive constant. So it's like your bandwidth you're going to use plus X amount of extra bandwidth. It's like not like a constant multiplier, just add. So like, let's say whatever bandwidth you were going to use plus like one megabyte, something like that would be an example of a potential setting. How do we do that? Oh, it's a great question. Talk about it later at the bar, because it's like very in depth how that specific system works. But yeah.
Just curious, how do you go about choosing a good reliable VPN? There was a story on Slashdot last week about how supposedly a third of the VPN providers are have links to the Chinese government. And the top-rated comment to that was, guess which government the rest of the VPN providers have deep links with. So
yeah, choosing a good VPN. So yeah, it's a hard thing. So speaking of that, so these state attacks on VPN users, very real. There's actually a big problem in some countries where if you Google free VPN, what you get will 100% of the time be a free VPN provided by the state that is logging all of your traffic. And in fact, what they do is they block all of the websites to the real VPNs and then put up fake websites where you can download their software, which may actually be the real software with malware bundled into it, and so hard to detect. So yeah, you really got to be very careful. One tip: never use a free VPN, because there are no free VPNs. People aren't just making services to help you. We are. We don't provide service.
Server
We make
farms are
technology.
expensive. They have to make money somehow.
Yeah, there are a few free VPNs that work, but I would say generally you should pay for a VPN service, which does not guarantee that it is not bad. It just is if it's free, it's definitely bad. And then it's tough. So I like TunnelBear because we know the developers of TunnelBear, and they use our obfuscation technology, and I just think that they're nice people that. I believe in my heart that they are not stealing my data and selling it to governments, but I have no evidence of that. That's just my feeling. So you got to go with what you think, who you trust.
Computing resources are very, very cheap.
That's
Just do
what they're
that.
audited publicly. They
Yeah.
were the first VPN to go through and do public auditing for their users.
Are there
Yeah.
ones besides Tunnelberry you feel positively about, and are there ones that you're like,
Yeah,
oh
yeah,
God,
yeah.
do not use that
So
one?
yeah, so other ones, and these are our friends. So it's like, you know, that's partly why I liked them is I know them and they seem like nice people. So if you have other friends, like maybe you use their VPN. But one of the big ones internationally is Siphon. It's pronounced siphon, but I just like to say siphon because it's like a word in the English language. But yeah, so that's very popular. And then also Lantern is a really nice one that I really like, very easy to use. So yeah, those are probably my top picks. Tor is great. Tor is because it adds all this additional stuff besides just the like circumvention. Tor can be slower than other tools. So like you gotta use Tor like when you're doing something like some people can like stream YouTube over Tor. For me, it's not that effective. But if you're like checking your email or something, Tor is excellent. So yeah, there's a bunch of good options, you know, that you can get right now. And Tor even like they have like phone versions of Tor now, so you can like run on your phone. It's cool.
I might regret asking this, but do you have any thoughts on our local VPN, Viper VPN?
I cannot speak on that because of NDA reasons.
Oh, I forgot you used to work for them. That's right.
We don't need to talk about that.
Okay.
I think Viper VPN is great. I think that's a great one. You should check that one out. They're local, so that's very cool. That's all I want to say about that. Yeah.
For everyone's, the company that makes TunnelBear also makes a password manager called Remember, which I'm pretty sure the app, when you log in and you get your password wrong, the bear will look uncomfortable.
Yeah.
He gets sad.
Yeah, he gets sad.
Yeah, I love the little.
Which
They're
is
great user
probably the
experience.
best user experience I've ever seen.
Love that bear. Really makes it fun. Okay, we got time for some more questions. Yeah.
Yeah, we got one more time.
So speaking of VPNs and how you guys have worked with them in the past, have you heard of the VPN protocol WireGuard?
Have I heard of WireGuard? Yes. So we actually have totally just unofficially as fans of WireGuard been talking to the WireGuard author. I'm on the WireGuard like IRC channel and stuff like that. So yeah, basically what I said to the WireGuard team is you should have all this obfuscation technology in WireGuard. Wouldn't that be great? Because WireGuard is like not as popular as OpenVPN yet, but when it grows in popularity, it's going to be just as blocked as OpenVPN, which is like to say a lot, like blocked everywhere. So you should get on the bandwagon now and put in this obfuscation technology. And we had some conversations about it, and it has not yet come to a point in which they have made the changes to WireGuard necessary for us to put in the obfuscation technology. But if we have the opportunity to do that someday, I would love to do that. We're just big fans of WireGuard. Like we have no official relationship with them. We just would like love to do some work. I love Wire. It's a great protocol. Yeah, it's very cool. And but yeah, I looked at the code and everything. They do some very interesting stuff to make Go code run on iOS, which is like almost impossible. And they're like really have it kind of working. And so it's like very cool, cool team, the WireGuard team. But yeah. Yeah.
You talked about how some of these adversaries are using pretty outdated hardware and stuff. Have you overseen the probing of China and Russia, and if so, do you have an opinion on how sophisticated they are as far as their obfuscation and what their motivations are?
What are you asking about specifically?
Just kind of a curiosity thing about what's your opinion on China and Russia's obfuscation?
Well, I can't talk about any specific countries, unfortunately. But what I will say on general note is that there are kind of two classes of hardware that people have. There's the hardware that people buy that's like off the shelf, which, especially if they bought their hardware a long time ago and haven't updated it, is very old and doesn't have all the new capabilities. And then there are a few adversaries that actually build their own hardware, and then they have a huge advantage because building their own hardware, they can just do a lot more sophisticated processing. But yeah, I can't talk about specific countries just because if we have users in specific countries, I don't want to put them in any kind of danger by. So if I start talking about specific countries, I might be like, oh, when we do this in this country, do this in this country, and that might like undermine their ability to use those techniques effectively. So yeah.
Bears and pandas. So you have to get that's why you talked about Australia, right? Zero.
Yes, we don't do any work in Australia. I should get this slide of Australia out. Oops, totally.
Yeah.
I had a bonus slide, but no one asked the question yet, so I can't.
So, sorry, I came late, but I'm from Sudan. I come from Sudan.
Oh, Sudan.
Where we had peaceful demonstrations and
Yes.
revolution going on from
Oh, yeah.
December until July.
Yeah.
On the 3rd of June, we had a total internet shutdown because of a massacre that resulted in more than almost 200 people killed. And the country has been without internet for the past 36 days.
Yeah.
It was open today, early this morning. So, people tried everything, of course. I mean, we talked with everyone. Google, the Facebooks, the government, all over the world. And with total internet shutdown, there is nothing much you can do. So this is one. So I saw the slide about total internet. So I missed that. So
No, that was a bonus slide. I was waiting for someone to ask me about total
internet. And then the second thing, now that the internet is back, what can we do?
Yeah. So total internet shutdowns are more and more common across the world. Anyone that has done a total internet shutdown last year will probably do one again this year. So that's where you just turn off the whole internet. And none of our software works because there's no internet. If you allow some traffic through, we can probably have a mechanism that will get your traffic through. But if there's no traffic allowed at all, then there's like nothing you can do. So unfortunately, my slide does not address Sudan specifically. So this is Corey, who's on the board. We're working with these satellite internet systems. So really, all you can do if there's a total internet shutdown is provide some sort of alternative channel. It's not going to replace the internet, but it can be a way to communicate while there's no internet. And so you're going to be using one of like several mechanisms. There's only a few ways to transfer information, right? It's going to be radio waves, or it's going to be a cable, or it's going to be light, or it's going to be sound, or it's going to be like physically moving like things with data like across the border.
In station wagons.
Yeah, right. Exactly. Those are all the mechanisms. There's no other mechanisms of sending data, so it's going to be one of those.
I know you've in the past often said the Iridium satellite network's one of the best options usually.
Yeah. So we're working with a bunch of different satellite technologies. So unfortunately, this isn't relevant to Sudan because all satellite technology, I have heard, is not allowed in Sudan.
Yeah, the logistics of bringing in this equipment is really tough during these.
Yeah, and so that again goes to the point of like every country is different. So we're doing this. What's up?
Go ahead and finish.
Okay. So we're doing this satellite stuff, and it will work in most countries. Like Iridium is a technology that works over the entire Earth. Every single point on Earth has Iridium coverage. So that's awesome. But some countries do not allow you to bring Iridium equipment into the country, and so and like Sudan's one of those, and so we're working on. This is kind of where we're heading to now as an organization is to do total internet shutdown mitigation by providing hardware to people that allows them to use different satellite and radio communication technologies. And it's going to be different like per country because every country has different needs and different regulations and things like that. But yeah, I was at RightsCon, which is a big human rights conference during the Sudan stuff, and everybody was talking about it and saying like, what can we do? And technically, like technologically, we there's not really much you can do if you can't get the communications equipment into the country. It's like a very limiting problem. Yes.
So speaking of Iridium, now we have their newest brethren, right, from Elon and even Bezos is starting to play, right? So are those things going to provide that kind of circumvention?
Yeah, so that's something people really have their hearts set on, this idea that these new networks are going to provide them with internet when they currently don't. What I say about satellites is if someone says, I'm launching a satellite and you're going to be able to use it, check back in 30 years to see if we can use it now. So like just getting the satellites in the air and like spread out into space into their like orbit slots is only one of many, many steps that will have to come to pass before anyone is able to use these for anything. and whether or not they decide to take the bold and unprecedented move in the history of civilization to say, you know what, we don't care, we're going to provide internet to all these countries that make it illegal, we're just going to do it anyway. That would be very surprising to me if they did that, but hey, that would be great because then we'd all have internet. So, you know, who knows? But I would say do not hold your breath on that stuff being, you know, like having subscriptions out like this year or whatever. Like we still don't even have Google Fiber, like where I live, so yeah.
So since, I guess it was March or April, I've been hearing, and I work in this stuff, so I've been hearing from overseas. You know, Russia's been talking about trying to have a shut down the internet. They're gonna isolate the internet, they're gonna have it going, it's not connected to the world. You heard anything new about that? Because last I heard it was stuck in Russian parliament, they have some law that they need to pass, but.
Yeah, well, I would say I can't talk about specific countries. I don't know anything about that specifically, but they wouldn't be the first to try this idea of let's just disconnect from the internet and have our own network that's not the internet, but totally fine. People have definitely come up with, no one has done it, but people have floated the idea of having, they call it, some people sometimes call it the splinter net, is when everyone disconnects from the internet, has their own internet. Some countries have been successful in essentially making their own local versions of popular internet services that people will use instead. So like alternatives to Twitter and Facebook and things like that that are localized to local language. All of your friends are on these services because they're, you know, in the local language and everything. And yeah, and then people use that instead. And of course, those services that are running in country all have to be censored and monitored, and you know all of the stuff the government wants.
Of course, this is where I think though that the international business community will probably insist that there be some means of hitting servers in other countries, no matter what. I could see Russian oligarchs being annoyed if they couldn't wire their money other places.
I mean, yeah, you can insist on stuff.
They've had ways of doing that for a long time.
So, on the spectrum of blocking, total internet shutdown is on one end of the spectrum.
Correct.
What is on the other end of the spectrum? Are there countries that are just like running into providing access as much as possible?
No, I would say.
So all governments are like trending towards the.
Yes, I mean once you have the devices, it's very tempting to turn them on, and once you turn them on, it's very tempting to fiddle with the settings. And so, yeah, I would say filtering overall globally is getting worse. I will say, and I'll talk about this specific country just because this is a happy story. Tunisia in 2011 had a revolution, regime change, and they actually turned the room where they did the internet filtering, the room with all the routers in it, with all the people that were looking at the traffic and blocking it, they turned it into an internet cafe that you could come, and they have free Wi-Fi, and they invited people from the internet freedom community to come and like just hang out, and they had a big party. So that was like since then, you know, Tunisian internet has been like a lot more free, and that's the only example I can think of where it went kind of backwards, and it just all of a sudden, just one day, they're like, you know what? Let's stop blocking stuff on the internet. I was recently in Tunisia. That's where this conference was, and yeah, I couldn't find any websites that were blocked, you know. And this was traditionally like a place that was doing like a lot of blocking, and they just kind of like unblock stuff. Yeah.
Sorry, just
Yeah.
to follow up, is like, besides job security, is like there anything to be hopeful for? Are we gonna be able to turn around the sentiment around blocking? Or is it just gonna trend that way and it's gonna be a game of cat and mouse?
I don't know. That's kind of like a policy question, so that's kind of outside of my realm of expertise.
That has to do with when you can actually use your slide theme.
Oh, yeah.
Yeah. So yeah, I don't know. I would say technologically we're doing a great job in the circumvention community. I don't know what's going to happen with the filtering. Maybe they'll give up eventually. Yeah.
A really specific question about your Tunisian experience. Did you have any trouble with your VPN or the obfuscation?
Oh, no. Everything worked great. Yeah, no problem. I used TunnelBear with the obfuscation technology that TunnelBear uses that we worked on. So yeah, it's yeah, everything worked great. Yeah, I had no problems with Tunisia. Real good internet in Tunisia. Very cool. The wine is great in Tunisia as well. Yeah.
In your opinion, do you think there's a market, like a want for some sort of privacy internet cafes or type of video, or if this technology should all just be bundled into browsers eventually, and so that the lay user doesn't have to like worry about what to install, what technologies they're using, where they're using them?
Yeah, this is a great question. So like Tor actually, that's their whole deployment strategy now, is that they have a product called Tor Browser, which is Firefox with Tor bundled and with all of these security patches that they feel are necessary pre-applied. So it's like a secured, like lockdown version of Firefox that when you turn it on, you are definitely using Tor. You don't have to configure it, you know?
I'm familiar with Tor browser, but my question was more related to people who have no idea what Tor is, have no concept of security whatsoever, just people who use their phone, use Safari, use Internet Explorer every day.
So you're talking about like a device level, like
Well, I'm
protection?
asking more about your opinion on the want for this sort of privacy.
Do people want it? Yeah, so what I would say is users don't care about privacy or security for the most part. They care about access. And so what we try to do is we try to develop private and secure tools that give them access, and then they get the tool for the access and then get all the privacy and security with it because we insisted on doing it that way. But yeah, in general, once they have the access, in my experience, users will, it doesn't matter how risky it is, like they'll just use whatever works. And that's why they're Googling free VPN and then just installing whatever software that they find. This is a very common thing to do. I wish that there was more of a active desire. Now we do work with some communities that are not like that. We work with some communities that actually understand the risk that they have and are willing to change their behavior and like use new software and like go to like workshops and like educate themselves because they're, you know, like, so like we worked with journalists in Mexico City, and so they were under like a real threat like of their lives, and they were like, maybe we should stop using unencrypted text messages to like communicate where we're going and when we're going to be there, and you know, because
so in that case, it's not as much government as it is cartels.
Yeah, so like in some parts of Mexico, like you can buy access to the government monitoring equipment. So you can just kind of walk me. I have somebody I need to monitor. You know, it depends. It's like region by region, but yeah. So what was my point? Yeah. So we are with some vulnerable populations that are willing to, like, they understand that they need privacy and security, but the average user doesn't really seem to value it. More questions? Yeah.
Does the U.S. This may sound naive, but. And you said you can't talk about countries, specific countries, but I wonder what the state of blocking is in the U.S.
Well, that is something I can talk about because we don't do any work with the U.S. because there is no blocking in the U.S. Of the sort that we work on. So the only time that I've experienced blocking in the U.S. is corporate based. So like if you're at a coffee shop, you're using free Wi-Fi, sometimes they install this, they have like a service that provides the free Wi-Fi. Like they didn't have their own router. Like one of these, you know, like internet for coffee shops comes in and they give you, they have their own filtering like installed, and they will sometimes block things that I need to access, like things like Tor or like VPN providers, like things that I'm doing for work. They will block it because once you install the VPN, then you can get around whatever other blocking they were going to do. So they just go ahead and block all VPNs, which I think is unethical, but that's what they do. And so that's the only thing that I've experienced. Now, here's an interesting thing about, in the US context, libraries, if they take federal funding, are required to install filtering, but they're not required to turn it on or configure it or to filter anything specifically. They're just required to have the filtering technology installed in the library. And so that's a big debate among the librarian community is, you know, like what should we be filtering in libraries and like what should we be letting people access? Generally, people that work in libraries are freedom of information advocates and like activists. And so usually they keep it pretty loose, but yeah, it's required for them to have that. So there are some instances, but it's not at the national level. We have very much in the U.S. a privatized internet system, and so in order to get anything to happen, you would have to get like AT&T and T-Mobile and Verizon and all of these like people you've never heard of, like level 3 to all get on board. It's not like you can just pick up the phone, call one person and say shut it down, and then they shut it down. It would be very difficult to have any kind of like in the U.S. we would definitely, someone would have to pass a law to make certain things illegal in order to get them filtered. Any more questions?
I would add one thing on that, Brandon.
Oh, go ahead.
One thing that we may not realize as U.S. citizens is a lot of the content we use is not filtered necessarily at a hardware level or at like the physical internet level, but we do have a lot of our content filtered by these providers. For example, if you look at the results on Google versus DuckDuckGo, the things that surface are completely different for the same searches. So like the content that we receive is filtered, but not like at a hardware level by these individual companies. And you'll even see it like on Facebook, there are things that you can't necessarily access or share. Like if you've ever tried to share a link and they say, oh, you can't do that because it looks like spam, even though it's your own family photo.
And in fact, even further on that, not just are there certain things that you'll see differently, like say on DuckDuckGo, because they're not using what they think you like to decide what to return to you, but I don't know the full accuracy of this, but there's even been scattered reports that Google, for websites that are like more than 10 years old, is just not indexing them and returning them anymore.
Absolutely.
That there's vast hunks of the early internet you literally can't find in searches with Google anymore because they don't think you'll be interested and it's not profitable to them.
Yeah, but this is all based on corporate policy and is not a form of human rights like repression, which is why we don't
Right,
deal
like I was
with it
saying,
at
it's
all.
not a hardware filtering, but like maybe a lot of people don't realize their content is absolutely being curated and manipulated. Yeah.
Yeah, curated is the nice version.
As a designer, we say curated.
Yeah.
So can I get the show of hands again of who here is a programmer with network experience? Anybody? Okay. Email me because we're hiring, and you could come work. You could come work with us on this sort of stuff. So just you got my email right up there. You know, send me an email. And I guess let's go ahead and close it down and move on to the
Thank you all again for coming. I also just want to let you know that usually after the meetup, we adjourn to Firehouse Hospital and Lounge, which is about a block away for drinks and non-presentation chatting. So any of you who want to join us for that are welcome. And for those of you who don't come, I hope we'll see you next month. Thank you.
I'm going to this.
Oh, great. I'll see you there.
We can hang out.
Oh, jeez.
Spent time with kids. Serious.
Don't say
That was really great. So, you want to try to do this Friday? Would that be okay for you?
I mean, Friday, I'm trying to think, as I said, I work on the east side off Springdale, but I'd be down maybe somewhere for a coffee or lunch.